Alright, so Unit 8 is about probability and statistics, and some of this stuff might be a little bit of a review for you, which is great. That means that we can then take those ideas and extend them a little bit. So when we think about um, probability, some things that may come to your mind would be a percentage, um, oops, how likely something is to happen, and you maybe think, a ratio. So there may be some other words that come to mind when you think of probability. So these are just some that came to my mind. So let's look at this first example. A sporting goods store offers two types of bikes, mountain racing and three different wheel sizes, 20, 22, and 24. Now, we're asked to find out how many bicycle choices does the store offer. So we have a mountain bike, and then we have our racing bike. And then in a mountain bike, I could have a 20-inch, a 22-inch, or a 24-inch. And same thing for a racing bike. So we could have a 20-inch mountain bike, a 22-inch mountain bike, and a 24-inch mountain bike. And we could have a 20-inch racing bike, a 22-inch racing bike, or a 24-inch racing bike. So we have 6 different options. Now, a shortcut that you could do to get this answer is to multiply your choices. We have 2 different types of bikes and 3 different wheel sizes, so 2 times 3 gives you 6. And again, if you're unsure that, you can always draw it out, but as you will see later on, drawing it all out could take a lot of time. So let's look at number 2. A restaurant offers 3 different appetizers, 2 different salads, and 4 different entrees. Find the total number of choices to complete a meal if you order 1 appetizer, 1 salad, and 1 entree. So be careful to make sure you're actually answering the question, because what if the question just said if you order 1 salad and 1 entree, the number of appetizers wouldn't matter if that's what the question was asking. So just make sure you read the question carefully. That's why I like to underline things that go together. So we have 3 different appetizers. We have 4 different salads. And we have, 2 different salads. 2 different salads. And 4 entrees. And that gets us 24 if we multiply them. So 24 different meals. Now, number 3 says the restaurant also offers 5 different dessert options. How would this number change if you wanted to add a 5th dessert? Well, if that was the case, we would take the same thing we have up here and then multiply that by 5. So I'm going to take this 24 from above and then multiply that by the number of dessert options we have, and that gives us 120. Now, you could still do 3 times 2 times 4 times 5 to get 120 as well. We get the same thing. So just you need to look at it and see, okay, how many of each different choice do I have, and then multiply the number of options you have. Some new vocabulary. Factorial. Factorial, its symbol is this, And what it means is that you multiply by the number and go all the way down to 1. So like 5 factorial would equal 5 times 4 times 3 times 2 times 1. And then you would type that in the calculator and get your answer. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, on the graphing calculators, there is a factorial button. So if you hit like 7, and then you hit the math button, which is just under the alpha key, okay, then you're going to press over all the way to where it says PRB, and you see the fourth one here down is that exclamation point. You could type it that way. But for some of you, and for some of these problems, it might just be easier to type 7 times 6 times 5 times 4 times 3 times 2 times 1, and you get the same answer. Now, another term we're going to talk about is something called the fundamental counting principle. And in my own words, what that means is we're going to multiply by how many choices we have to get the total number of possibilities. So like when we were talking about the restaurant in number 2, we had 3 different appetizers, 2 different salads, and 4 entrees, and the problem says I'm going to take one of each, so I multiply the number of appetizers times the number of salads times the number of entrees. So that's, in a nutshell, what the fundamental counting principle is. All right, let's look at the next page. So the standard configuration for a Texas license plate is 1 letter followed by 2 digits followed by 3 letters. How many different license plates are possible if letters and digits can be repeated? So what I'm going to do is I'm going to draw out 6 dashes or 6 spaces because there are 6 spaces in our license plate. So for the first one, we got to think about how many different options could I have there. I could have any letter of the alphabet, A, B, C, D, all the way up to Z. And remember, there are 26 letters in the alphabet. So I have 26 different options that could go first. Now the next thing, or the next digit has to be, the next part of the license plate has to be a number or a digit. So 0 through 9. A lot of people forget 0 could be a digit, so there's actually 10 different options there. You have the numbers 1 through 9 and then 0. Alright, so then I have another digit, and then the last three are letters again. So 26, 26, 26. So then you would just multiply all of those. So we're going to multiply these in my calculator, and you get a honking big number. It is 45,697,600. So there are 45 million different license plates that we could have here. Now part B says how many different license plates are possible if letters and digits cannot be repeated. Okay, so that changes things a bit. So I'm going to start with my 6. blanks, or my 6 character placeholders. And again, the first letter could be any letter, A through Z. So I have 26 options. The next character could be any digit, 1 through 9 and then 0. So I have 10 options. Now, the next character in my license plate cannot match what I have right here. So if I have a 7 right here, then this one, the next one, can't be a 7, can't be the 7. So I only have 9 options because these two can't match. And then we go back to letters for the fourth space. Well, again, I have one less option here because the first character in the license plate I've used up. I can't use it. So if it starts with a C, then this one cannot be C. So I have 25 options. And then I have 24, and then 23. So when I multiply all of that together, it's still a big number, but not as big. It is 32,292,000. So by having no repeats, we lose about 13 million options. So for the you try ones, I'm just going to set it up, and then I'm going to have you pause the video and try it. So again, it says you choose a password with 4 letters followed by 3 digits. So we have 4 letters followed by 3 digits. So go ahead, pause the video, and once you've tried this, unpause it and see if you get the same answer. Okay, so these are the answers that I got, and I wrote out how I multiplied them. For letter A, we cannot repeat our letters or numbers, and for letter B, you can repeat. So again, each password is 7 characters, but the first 4 are letters, and then the last 3 are digits. Alright, let's look at number 5. So if we look at this, it says 8 runners compete in an elite track meet competition. Assuming there are no ties, in how many ways could the runners finish the meet? So if we have 8 runners, we have 8 different places that someone could place. They could place first, second, third, fourth, fifth, sixth. First, second, third, fourth, fifth, sixth, seventh, and then 8th. So 8 people could finish first. We have 8 people running. Any one of them could finish in first place. Well, the next one, the person who finished first cannot also finish second. So there's only 7 people who could finish second. And then for third place, the person who's finished first can't be in third, and the person who finished second can't be in third. So there's 6 options. And then it goes all the way down to the last place. And if you were to multiply all that, that gives you 40,320. Or you could have said, wait a minute, this is the same as 8 factorial. And yeah, if you type that in your calculator, you would get the same thing. Now, letter B is a little bit different. It says, assuming there are no ties, in how many ways could the runners place first, second, or third in the meet? So this one is saying that we only care about first, second, and third. We don't care about any of these down here in this area. Let me highlight that instead. We don't care who's 4th, 5th, 6th, 7th, and 8th. We only care about first, second, or third. Okay, so since we only care about first, second, and third, I'm only going to have 3, blanks for me. But again, there's 8 people that could finish first, 7 people that could finish second, and then 6 people who could finish third. And then when you multiply these together, you get 336. possible ways that we could have first, second, and third place. So it's far fewer than letter A, but it's because we don't care about anything after third place. Now, number 6, we have a baseball team that has 14 players. How many 9-player batting orders could be formed? So we can only pick 9 of them. So I'm going to have 9 blanks. So if I can only pick 9 players, or sorry, if I have to pick 9 players and I have 14, that means some are going to get left out. So for my first person in the batting order, I have 14 options that I could pick. Well, in baseball, you can't have the same person batting in the order in 2 different spots. So if I put someone here at the first spot, they can't be second spot as well. So I only have 13 options here. And then I have 12 options. And then 11, 10, 9, 8, 7, 6. So yeah, not everyone is going to get to bat, because once I get down to the 9th person, I still have 6 people who I could pick. So when I type that into the calculator, we get a really honking big number of 726,485,760. So what we just did in that problem was we calculated something called a permutation. And a permutation is a way to select possible outcomes by selecting a group from a larger group. Order is important. Okay, so you all know that I am a hockey fan, and all the hockey teams are ranked. And when you're talking about the entry draft, they're ranked in reverse usually, where the worst team gets the first pick, the second worst team gets the second pick, and so on. So something like that would be a permutation, where in hockey they take the 15 non-playoff teams and then they order them to see who picks first, second, third, and so on in the draft. So order does matter, because you do want to make sure, if you're a team that is not good, you want to make sure you're picking up high. So order does matter for something like that. We will talk more about that tomorrow, how to determine if order matters or doesn't matter. So that's it for this video. Make sure you hit the like button and subscribe. I will see you guys later.